Welcome back for the final lecture of this week. So we had started talking about text classification and we discussed the naive model for text classification. And today we will take a working example on how do we use naive model, and then we will discuss various other issues with classification and also talk about the evaluation of classification. So let's take an example. So what you are seeing here, so your training set that contains 4 documents, document 1 to 4, and so document contains some words. So like one contains Chinese, Beijing, Chinese, and so on, and there are some labels assigned. So this document corresponds to class C, that might be Chinese, and this corresponds to class J, that can be Japanese. And then in test data you have one document, document number 5, that contains Chinese, 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 Tokyo, Japan, and you want to assign it to one of the class, one of these 2 classes. So how do we solve this problem using naive model? So remember, what is the naive model? We need these 2 probabilities, P hat C and P hat W given C, for all these 3 words. So let us try to compute these probabilities. So I have class C, I have class J. So I need to find out what is P hat C and P hat J. So what will be P hat C? That is the probability of class C in my trained data. So it occurred 3 times out of 4. So this will become 3 by 4 and this will become 1 by 4. Okay. Then I need to compute different probabilities for words. So what are the words here in my test document? I have Chinese 3 times, then Tokyo once, Japan once. So these are the documents in my test data, test document. I want to assign it to some class. And what will be the probability of these 2 classes? The probability of class C would be P hat C times probability Chinese given C to the power 3, because it is occurring 3 times, probability Tokyo given C, probability Japan given C, and this will be P hat J, probability Chinese given J to the power cube, probability Tokyo given J, and probability Japan given J. So now I already know this and this. So I need to compute the other 3 probabilities. So how do I compute probability Chinese given C? This would be number of times the word Chinese occurs with this class, count of Chinese with C, and I am using advanced smoothing, so it will be +1 divided by all the words that occur in the class Chinese. So I can call it the number of words in class Chinese plus my vocabulary size. Now what is the vocabulary size here and what is NC? Let us see. Similarly, you can compute probability Chinese given J as count of Chinese in class J +1 divided by number of words in class J plus my vocabulary size. So let us see from the documents how many times the word Chinese occurs in class C. So it occurs 1, 2, 3 times. Actually 1, 2, 3 and 4 times. In class J it occurs once. What is the vocabulary size of Chinese? 1, 2, 3. Not vocabulary size, how many different tokens are there in class Chinese? 1, 2, 3, 4, 5, 6, 7, 8. In Japanese 1, 2, 3. And vocabulary size, how many unique words? 1 Chinese, Beijing, 2 Shanghai, 3 Macau, 4 Tokyo, 5 Japan, 6. So I now know all my variables, so I will write it as this came out to be 5 plus 1 divide by number of words in class Chinese are per 8, vocabulary size was 6. This comes out to be 6 by 14. What about this? So number of times Chinese occurred in class Japanese was once plus 1. Number of words in class Japanese were 3 plus 6. So this comes out to be 2 by 9. Okay. Similarly, now you will compute the other two probabilities. That is probability Tokyo given C, Japan given C, and Tokyo given J, Japan given J. So let's see these on slide. So once you know how to do that, we can see that quickly on the slide. So first you compute the priors that you know are 3 by 4, 1 by 4. Then you compute all these conditional probabilities. So we already computed probability Chinese given C and Chinese given J. Let's see the other two. Tokyo given C would be number of times Tokyo occurs in class C 0 plus 1 1 divided by 14. So denominator will remain the same. Tokyo given J will be 1 plus 1 2 divided by 9. Similarly, Japan given C will be 1 by 14. Japan given J will be 2 by 9. And that's what you see, 3 by 7, 1 by 14, 1 by 14, 2 by 9, 2 by 9, 2 by 9. Now, can you compute the probability of class C given document 5 and probability of class J given document 5? That again comes out to be the same formula that we wrote, and we have now all these values. So you put all these values, so this will be 3 by 4 times 3 by 7 to the power 3 times 1 by 14 times 1 by 14, and this will be 1 by 4 times 2 by 9 to the power 3 times 2 by 9 times 2 by 9, and that will give you okay, class C has a higher probability than class J. So then this document D5 will be assigned to class C and not to class J. And this is how you use naive Bayes model. It's very simple to implement, and you just need to compute the probabilities of different words given different classes and use advanced smoothing. So now, so we saw how do we use naive Bayes model for classification. Now, so there is one thing that I want to discuss is that how this is very close to the language model topic that we had discussed. Okay, so how you can think of naive Bayes model as some sort of language model also. So in general, when you talk about naive Bayes model, it is generic enough that can use any feature. So you can use, so for spam detection you can use what are the URLs, what are the email addresses, you can use some dictionaries, right, whether this word occurs in one of these dictionaries, what are the network features, for example how many times you are getting emails from this person and so on. So you are allowed to use all these features inside your naive Bayes model. But suppose you are using only the content features, that is what are all the words that are occurring in this text. So if you use only the word features and all the words in the text, then it has a very important similarity to the language model. And what is the similarity? If you think about it, so it is like as if for different classes you are having different language models. So suppose you have a positive class, a negative class, and this is as if you are building language models for each of the class. And then when you have a document at the test time, you are finding out which of these language model assigns a higher probability to this new document, and that is the class of the document. Okay. So this is an important similarity of language modeling and naive Bayes. So you can think of each class as a separate unigram language model. So let's see some example. So like suppose you have two classes, positive and negative. Now from training data, you know what are the sentences that have labeled positive, you know sentences that have the label negative. So take all the documents with the label positive as one corpus and construct a language model out of that. Call it your language model for the positive class. Similarly, take all the words from the or all the documents from the negative class, take it a new corpus and build a language model, unigram model, call it your negative model. And now you find out the probability, you have the probability of different words as per these classes. Suppose like your positive model gives a probability of 0.1 to I, 0.1 to love, 0.01 to this, 0.05 to fun, and 0.1 to fill. So that says okay, in positive class you have a lot of times words like love, fun, etc. coming. On the other hand, in negative model you won't have these terms quite often, so you will have I is occurring much more times, but love is occurring like point with the probability 0.001, fun with 0.005, and so on. So now what will happen? At test time, when you see a new document. So when you see a new document, you will have a backwards representation. You know all the words. Now try to assign this a probability as per both of these models. So what is the probability for this sentence? I love this fun film as per my positive model, and what is the probability for this sentence as per my negative model? And then you will see that immediately. So positive model gives me a much higher probability than negative model, and you can assign it to the positive class. And you can see that this is very much resembling what you did in the naive model, except that in naive model you will also assigning a prior probability to each of these classes. So here, if both classes are roughly coming equal number of times in the data, then this is like they are very much similar. Either use language model or naive Bayes. So this is another way of thinking about this problem. So think as if you can construct different language models for each of the classes and try to assign probabilities as per different language models. Now, so we talked about the case where there are two classes or multiple classes, and a test document can belong to one of these classes only. Okay, so you will use your naive Bayes model or any other model and find out what is the class that will be assigned to this test document. But suppose we are talking about a multi-value classification problem. So what is a multi-value classification problem? A document need not be assigned to one and only one class. So it might happen that the document does not belong to any of the classes. So it belongs to 0 classes in the set. It might happen it belongs to one class, or it might belong to more than one classes also. Okay, so that's where your categories are not mutually exclusive. Okay, so a document can belong to many of the categories at the same time. So then, how do you solve this problem? Using whatever we discussed, whatever technique we discussed. And a simple approach would be you make different binary classifiers for each of the classes. So you have capital C classes, you have different binary classifiers for each of the classes. And given a test document, you try to assign a probability of this document to belong to each of the classes separately. Okay. So what we are saying, suppose you have C1 to Cn n classes. So what you will do? So you will take one class and build a binary classifier gamma 1. The document belongs to this class or does not belong to this class. Gamma I, gamma n. So n different classifiers. How will you build this classifier? You need the data. So C1 will be the positive examples. What will be the negative examples? Everything that is not C1. They are the negative examples. So you can take any of these classes. Okay. So similarly, you can build all of these classifiers. Now, once you build these classifiers, given a document at test time, test document, you will run all these classifiers and find out whether it belongs to class C1, C2, C3, and so on. And whatever the classifier says yes is the label given to the document. So it might say yes for two classes and it gets two label. The classifier might say no for each of the classes, then it will not get any label. So this in general excuse me, solves the problem of multi-value classification, where each document at test time might be given multiple different labels. So what are we doing? So for each class in my set, you are building a classifier gamma C that distinguishes this class C from all other classes. Then given test document D, you are evaluating its membership in each of these classes by the classifier gamma C, and wherever gamma C returns to, that is the label belonging to that document. So document by this way can get many of the labels. Now this is a multi-value classification. On the other hand, you might have this one of a mutually exclusive classification, where each document can belong to one and only one class. So we can always handle this problem by defining multiple classes for my naive Bayes model. But suppose I am trying to build binary classifiers. Okay, So how do I handle this with binary classifiers? So what you will do here, for each classifier C, for each class C, you build a separate classifier, like the way we did here. You build separate classifier for each of the class H. So till here everything is same. So each class H you are having separate classifiers. Test document, you again run various classifiers. So like gamma 1, tell me whether C1 is the, so now instead of just saying yes and no, what you will say? You will say what is the probability that this classifier gamma 1 is giving to class C1. What is the probability that gamma 2 is giving to C2? What is the probability that gamma 3 is giving to C3? You will get all these probabilities, and whichever probability is the maximum, you will assign that class to the test document if the classes are mutually exclusive. So if they are not, you will simply take the decision in each of the cases. If they are mutually exclusive, you will find the probabilities and take the max. So that is another approach. So given test document D, you evaluate its membership for each of the classes, and D will belong to the class with the maximum score. So that is how you can build multi-class classification by using simple binary classifiers. So now let us talk about the evaluation part. How do we evaluate our text classification approach? So in general, assume that you have some n number of classes, and so what do I mean by evaluation? So you will have a training data to train your classifier, but there will be a test data where you will find out how good your classifier is predicting the classes. So at test data, what will happen? You will have some documents. So D1 to some Dn, and document into your test data. Now you will run your classifier for each of these n documents, and you will predict it a class. Okay. Suppose you say, okay, this belongs to class C1, this belongs to class C3, this belongs to class C4, this belongs to class CK, whatever. Okay. And like that, for each document you are assigning some class, separated class. Now how do you know how good your model is? You have to compare it with the gold standard or the ground truth. So then you can say that what is the true class? Suppose this is actually C1, this is C3, this is C2, this is C4, and so on. This is the true class, and you want to match the true class with the predicted class. So what are the different evaluation measures that can be used to compare this with this? One is the simple accuracy. What fraction of times your classifier gives the same answer as the ground truth? That is one thing, but this is not very popular. There are some other measures like precision, recall, and in precision there are two variations, micro and macro. So let us see how do we compute all these different evaluation measures. For doing that, the first thing you need to do is to convert this whole thing into a confusion matrix. So what is a confusion matrix? In confusion matrix, what you will have for each class, how many labels were there in the predicted in the true class, and how many you could predict. So it will be like a so it will be how many you got it correct, how many did not get it correct. Everything will be there in that confusion matrix. So let's see one example. So suppose I have here 6 classes: UK, poultry, wheat, coffee, interest, and trade. Okay. So you are seeing the rows are true classes. That means how many documents in these classes, and this is assigned classes. So now how do you read this matrix? So what does number and 95 means? 95 means that your classifier assigned 95 documents to UK and they were true, but this whole column corresponds to whatever you classify assigned as UK. So it assigned 10 documents to class UK while they were from class wheat. So immediately you can see that my classifier has some confusion between the classes UK and wheat. Okay. So that's why this is called the confusion matrix. Where is my classifier confusing? So 95 cases it assigned UK, it was actually UK. 10 cases is assigned wheat, sorry UK, but it was wheat. So let's take the another one. In poultry, what is happening? One case where it assigned poultry, but the actual class was UK. One case it assigned poultry, it was actually poultry. 90 cases it assigned poultry, but it was actually wheat. So that means the classifier is really confused in that it is assigning poultry to 90 documents that were actually wheat. And similarly, you can read all your confusion matrix. So now from this confusion matrix, suppose I ask you a simple question like, how many documents in the test data did classifier assign to class UK? And you can simply add all these, say 95 plus 10, 105. How many did it assign to poultry? 1 plus 2, 1 plus 1, 2, 92, 93. So on. How many documents were actually belonging to class UK? So that's why you have to read the row corresponding to UK. 95, 96, 109, 110. 110 documents belong to class UK. So now, suppose you have this confusion matrix, you can find out where your classifier is getting confused and all that, and you can try to define your classifier with this information. But now suppose you have this final confusion matrix and you want to now see what is the precision of my classifier. So let us say we try to find out precision, individual precision. So what is the precision of the class UK? By precision I mean whatever documents my classifier is assigning as UK, what fraction of them are actually UK. So let us see, it is assigning 105 documents to UK, 95 of them are actually UK. So precision for class UK would be 95 divided by 105. Now what would be the recall for the class UK? Recall means among whatever documents that are in the class UK, what fraction of the documents could my classifier accurately classify. So here there were 110 documents in the class UK, my classifier could accurately classify 95 of those. So recall would be 95 divided by 110. Like that you can compute for each of the classes, the individual precision and recall. So recall would be what are the fraction of documents in class I classified correctly, okay, and that you can see you can get by adding over all the elements in the row, right. That's what we did for the class UK, added all the elements in the row. CII divided by summation over CIJ for all j. And precision, fraction of documents that are assigned to class I that are actually about class I. So this will be again CII divided by, now you will add the whole column. So summation over I CJI. And accuracy would be add all your diagonal elements divided by the total number of test documents. That will be your accuracy. Now we say that we can also compute the, so this is for each individual class, and accuracy you need to talk about the overall test data. But can you compute precision for so micro and macro average precision for this test data? So what is this? So if we have more than one class, then how do we combine the performance measures for individual classes to make a single evaluation measure? That's my micro and macro average precision. So what is the difference? So in macro average, what I will do, I will compute the precision or precision for each in the individual class, and I will take an average over each. Okay. Suppose my class 1 is having a precision of 0.7, class 2 is having a precision of 0.9, I will take an average, 0.7 plus 0.9 divided by 2, 0.8. In micro average precision, what I will do, I will first take all the decisions and compute a single metric over all the decision over taken together. So I will see how many cases are taking as true, false, I will take them together, make a single statistic or single contingency table, and I will compute my precision recall from there. So let us take an example. Suppose for your class 1, there were 10 cases where your classifier said yes and the actual answer was also yes. 10 cases were classified said yes, but they were not belonging to the class 1. 10 cases where you classify said no, and they were actually belonging to the class 1, and other 970 cases where classify said no and they were not belonging to class 1. And this is another way of writing the confusion matrix or contingency table for each class. Okay, so that is classify yes no, truth yes no. So from there, can you compute what is the precision for class 1? Okay, so it classify assigned 20 documents to class 1, out of them 10 were correct. So precision is 0.5. Now let us see the second class. In the same manner we constructed the contingency table. So what is the precision for class 2? 90 were assigned correctly out of 100 given by the classifier. So it is 0.9. So now when we have to do micro average precision, we combine all these statistics. Okay, so we combine these statistics to say okay, there were 10 plus 90 100 cases where classifier said yes and this was also yes. 10 plus 10 20 cases where classifier said yes, but it was not the correct class. Similarly 20 cases here and 160 cases here. So this you combine all these statistics into a single table, that becomes your micro average table. Now from once you have these tables, how do you compute your macro average precision and micro average precision? So macro average precision, you compute precision for class 1, class 2 take an average. So we already computed, this is 0.5 and this is 0.9. Take an average, so it becomes 0.7. So this is your macro average precision. Now what will be your micro average precision? So you will compute precision over this table now. So that will be 100 divided by 120. So that is roughly 0.83. So macro average precision comes out to be 0.7 and micro comes out to be 0.83. So now what do you see? So why micro is coming out to be higher than macro precision? So because in macro precision you are giving in equal weight to all the classes. You are computing precision over class 1, class 2, then you forget how many instances were there for each of the class. So and they are given equal weight and you compute an average precision. In micro average precision, what is happening? The class that is having more number of instances is getting a higher weightage. That's why it is biased towards class with classes that are having higher number of instances. So if you are building a classifier with multiple classes and you want to see that all your classes perform well, then macro average precision is a good measure. If your classes are imbalanced, some classes are having high number of data points than others. So micro average score is dominated by the score on the common classes. So when you're dealing with text classification, there might be some issues like in your training data, some classes are more common than others. So you have more samples from some classes than other classes, and this sometimes biases your classifier also. So a good strategy is that you resample the number of instances in the classes. So one simple thing is you can do undersampling. So if a class is very common, you undersample it such that it becomes close to the other classes that are quite rare. So that by that way, in your training data, you will have roughly equal amount of samples in each of the classes. And there are other algorithms that also allow you to oversample some of the minority class and so on. So we will not discuss that in detail. Just wanted to tell that it might happen that you have an unbalanced data set, then you have to do certain strategies before applying the classifier. So that finishes our week 11 for this course, and then so next week we will discuss in detail about the sentiment analysis and opinion extraction. So this will be a topic for the final week. Thank you.